This is our project for CS6923 machine learning course in fall 2016. Review-based rating prediction using machine learning. In this project, we present study of review rating prediction using review data from Yelp. Yelp works as a popular business review network platform. Users can submit individual reviews on local business, accompanied with 1 to 5 star ratings. We focus on predicting a review's rating from its review text alone. Since the rating results are discretely distributed from 1 star to 5 stars, we regard the prediction as a classification task rather than a regression task. We use the challenge dataset from Yelp as our project dataset, which includes information about local businesses in 10 cities across 4 countries of Yelp, and contains 2.7 million reviews. Data type includes photos, reviews, business attributes, check-ins, and tips. To be more specifically, we focus on the review type object. The JSON file has a size of 2.29 GB reviews object in total. The structure of review type object is as shown. Before using machine learning techniques, we perform some exploratory experiments to help better understanding of the data. First, we made basic visualization about the distribution of number of reviews in each star category. As Figure 1 shows, the review distribution of this dataset is skewed to the 4 and 5 star categories heavily, which consists of around 67% of the total reviews, while in the other hand, star category of 1, 2, or 3 only consists of 10% to 15% of total reviews. Star category of 2 consists of the least number of reviews. Then we did factor analysis based on the review text. The first attempt focused on the length of each review text and the number of reviews of such length, as Figure 2 shows below. Most of the reviews had length smaller than 1000, and the distribution of length versus number of each category is identical. We are curious about the word people tend to use in different rating review. Word cloud is a good way to show the results, so we try to generate the word cloud of reviews from 1 to 5 stars separately. We use the NLTK stopwords corpus as the basis, and also append some stopwords which are all the reviews have in common. Word clouds are then generated and as shown below. Then we begin our machine learning process by feature extraction. Here, we apply 2 popular methods for natural language processing and information retrieval: bag-of-word model and TF-IDF. We use multinomial naive Bayes and Bernoulli naive Bayes as our baseline algorithm. Since we have 5 classes for classification, which are 1 to 5 stars, it's good to see the confusion matrix of those 2 algorithms. A darker diagonal line indicates a better classification model. From the matrices, we can see naive Bayes is not good enough for this task, so we are going to try some other machine learning algorithms. It's previous that both algorithms try to predict higher stars for all the categories. For the improvements, we tested three algorithms, which are random forest, SVM, and neural networks. A random forest is an ensemble of decision trees, where each base classifier is grown using a random effect. After training n decision tree classifiers, it uses a voting schema to predict the results. In our experiments, we use the implementation in scikit-learn with Python. We use 30 estimators for our experiments. The confusion matrix below shows the prediction results. Support vector machines are really popular and strong machine learning algorithms used to do classification and regression. A support vector machine constructs a hyperplane or sort of hyperplanes in a vector space. The space can be high dimensional and infinite dimensional. For SVMs, the hyperplane would have the largest distance to the nearest training data, which is the max margin strategy. We use the implementation in scikit-learn, linear SVS, which is a kind of linear SVMs in our experiments. The confusion matrix below shows the prediction results. We also experimented with neural networks in our project. A neural network has several layers, and each layer has some neurons. There is an input layer and an output layer, and other layers are called hidden layers. One network can have several hidden layers. Each layer gets data from the previous layer and outputs data to the next layer. We use the implementation of chaos with just one hidden layer and 300 hidden neurons. The confusion matrix below shows the prediction result. We can conclude that in the YELP dataset, our algorithms for improvement, say random forest, SVM, and neural network, are better than our baseline algorithms. Furthermore, SVM and neural network are even better than random forests. We focused on predicting a review's rating of businesses listed in the Yelp dataset from its review text alone at this step. Our prediction method could be promoted to other platforms that only provide review text information. For further research, additional machine learning approach can be applied, and we can introduce it in more attributes as new features to try to get a better result. Thank you for your listening.